Okay, let's work on number 5. So we've done the first 4 questions, and on 5, I'm asking about the RAAS system. Before we start this, I'm going to be drawing, and I'm going to try to type out the steps instead of, how I like to write on this thing. Anyway, what I want you to think about is renin is coming from the kidneys, and angiotensin is being produced in the blood, and then aldosterone is being released from the adrenal cortex, different organ right on top of the kidney, but it comes back and affects the kidney. So actually, I'm going to write this. I'm not going to type it out. Okay, so if we have a drop in blood volume or a drop in blood pressure, then this is going to trigger this RAAS system. You realize that your kidneys control blood pressure long term, and this is one of the ways that it does this. I guess it's really the endocrine system doing it, but when blood volume and blood pressure drop, then the kidneys are going to detect that drop in blood pressure or blood volume, specifically around the afferent arteriole going into the glomerulus. You have those granular cells. They're the ones that actually detect this because they're mechanoreceptors, and they release renin. So kidneys detect this and release renin. Notice there's only one N. 2 N's is completely different. So when renin is released, already in the blood, your liver has made a protein called angiotensinogen. If it ends in ogen, it is inactive. And so I'm not going to fit it in here. Tensinogen. If we activate it, it just becomes angiotensin. And so blood volume, blood pressure drop, the kidneys detect, release renin. What renin will do is it will convert angiotensinogen, which is a protein in the blood made by the liver. Thank you, liver. Synogen to, what does it convert it to? We've had this in the endocrine chapter and in the urinary chapter. It converts angiotensinogen to angiotensin 1. Now we have angiotensin 1 in the blood. We did not have angiotensin 1 before. And so as angiotensin 1 is going through the blood vessels of the body, there are lots of capillaries. Well, all the capillaries are lined with endothelium, right? Some endothelial cells they have an enzyme attached to them called ACE. I only ever mention that these capillaries are in the lungs. We'll go with that. Angiotensin 1, it's in the blood. It goes to the lungs and is converted. What is it converted to? I'll wait for it. Angiotensin 2. Angiotensin 2. My water's boiling for my tea. Okay, so angiotensin 2 is something very important that you're going to need to know because it has some consequences throughout the body. First of all, we know that it's a negative feedback system, and we're starting up here with blood volume and blood pressure dropping. It's angiotensin 2 that's going to trigger the increase in blood volume and blood pressure, and it does it through a variety of ways. First of all, angiotensin 2, that's an S, tensin 2. It causes vasoconstriction. So anytime you're going to go from a diameter of this, if we're looking at the lumen of a blood vessel, to a smaller diameter, that's automatically going to raise blood pressure. So angiotensin 2 is a vasoconstrictor. This vasoconstriction, it is a direct mechanism to increase blood pressure. Another thing that angiotensin 2 does is it stimulates the release of antidiuretic hormone. Antidiuretic hormone is stored in the posterior pituitary. It's made in the hypothalamus, and its job is it's antidiuresis. It's to prevent the production of urine. And the reason we want to do this is because if we already have a low blood volume, if we make more urine, where are we getting the liquid? From the blood. So we want to release antidiuretic hormone so we don't lose more fluid to the blood. So it causes the release of, that's one of the reasons that it's released, causes release of ADH. Don't just abbreviate that on your final, spell it out. Antidiuretic hormone, we had it in the endocrine system. Angiotensin 2, what it's going to do is the next thing it's going to do, I've looked up, I thought, I'm not recording. I am recording. Angiotensin 2, the next thing it's going to do is cause the release of aldosterone, super important. Here's our hormone from that adrenal cortex that's actually going to go back through the blood to the kidney and tell the kidney, what's it going to tell the kidney? Resorb sodium, secrete potassium. So number 6, aldosterone targets the kidney. Probably pull this up a little bit. Aldosterone targets the kidney. Tubules, specifically, which kidney tubules? The distal convoluted tubules, because remember in the DCT, that's where we have hormonal control of the mineral regulation, like pulling calcium out of the urine, pulling sodium out of the urine, or secreting potassium. And so aldosterone targets the distal convoluted tubules to resorb, meaning we take it out of the urine, put it into the blood, we resorb sodium. Where sodium goes, water's going to follow. Now we resorb sodium and we secrete potassium. So that means we're putting potassium into the urine. Sodium and potassium usually go in opposite directions. And so this part about resorbing the sodium, when we take the sodium out of the urine and put it back into the blood, water follows. Well, the only reason water follows is it can, because when we release this ADHD up here, what's going to happen is we insert more aquaporins in the tubules of the distal convoluted tubule and the collecting duct, and that allows us for water to follow the sodium. So number 7, water follows sodium back into the blood. So this automatically is going to increase blood volume. And if we increase blood volume, what do? We increase blood pressure. So that is the answer to number 5. I think you've heard this before. It's just something you have to know. So, and if you're in healthcare, it's really something you're going to apply quite often. Okay, start practicing that when we have our study session, then we'll go over it again.